Hi everyone, today we'll talk about reflow profiling in a Pro 1600 reflow oven and how to create a profile. So there are basically two main ways of profiling. One is to use the traditional method of internal thermocouple control, and that is basically running a profile based on settings that are predefined that control the internal chamber temperature, and it's based on the feedback that was derived from the board, the product that was being reflowed, to make sure the curve of that board is within the profile window, the process window, based on the solder paste or the alloy that was used. So that's the method that's used in this oven. It's the same method that's used in any large-scale production ovens, basically creating a recipe specific to the board or set of boards that are being reflowed based on their mass and size and complexity. The other method is what we call an external thermocouple control or a closed loop control method, and that is used for essentially prototype builds or small lot builds. And in that case, there's no need to do the traditional profiling. Rather, we attach a thermocouple to the board and we specify within the software what we want this board to be subjected to. So we specify a preheat stage, peak temperature, and the oven will self-adjust based on what it's reading from that board and adjust the temperature inside the chamber to achieve that kind of a profile. And again, that's useful for prototypes. Somebody who's doing a couple boards, 5-10 boards at a time, and doesn't want to spend the profiling or doesn't want to spend the time to profile the traditional way because they're not going to rerun the board. So small lots, prototype builds, very useful. And in this example, we have one board on a loading tray, but you can have multiple boards, as many boards that will fit in this 20 by 20 inch matrix. So there's enough thermal capacity in the oven that will compensate for that additional mass, whether you have one board or you have 5-10 of them at the same time. The oven will self-adjust for that. So it's a single profile regardless of how many boards you have inside. And this is a single-sided board, but we can have double-sided boards. There's a fixture that can be placed on the loading tray, and it will secure the board along the opposite edges so that there's no contact, bottom side contact of that board with the loading tray with a mesh, and it creates a standoff. And in the software, if we're to do the traditional kind of a profile based on the internal control, we would initially go to open profile. We have a library of profiles we can select from, or use one of the pre-existing profiles for a similar board, use that as a baseline and kind of tweak it, make slight adjustments to that board or to that profile for slightly different board. But in this video, we'll concentrate on the external thermocouple control method, and I'm just going to modify some of the settings, the initial ramp rate, the peak temperature or the preheat temperature, and then to 40. So again, these are the settings that I want the board to be subjected to, not the settings of the inner chamber. And I'm going to select my control as the external thermocouple control. And click start. So the tray is going to slide in. We have the thermocouple mounted directly to the circuit board, and that's going to be our control. It's going to be based on that feedback temperature. The thermocouple we have is mounted over or placed over the seal. The cover comes down, presses against that thermocouple, and because it's a flexible seal, it doesn't cut the thermocouple, doesn't bend it. The other side of that thermocouple is connected to the side panel, and it's starting that cycle. So we're gonna run based on the board temperature as the control, and the internal temperature of the oven will self-adjust based on what we have programmed. On the graph, if we're gonna look at the graph, the red line represents the internal air temperature, while the blue line is the temperature of the external thermocouple. Again, this method does not replace the traditional profiling, whereby somebody's using the oven for production. They're running the same kind of a design or multiple designs over and over again. In that case, they will have a profile that's going to be saved, and anytime they run that board again, they're going to recall it, place the product in, select start, and have the system run that board. But for someone in the prototype environment who's designing a new board and doesn't want to spend the profiling time because they're not going to rerun it over and over again, this is a very useful feature to have. It saves a lot of time, and it gets the board within the process window of the alloy that's being used. Based on the data sheet, customers can look up a data sheet, but essentially a lead-free profile would have a melting point of 217, what's the most common, and the goal is to get to a temperature of 230 to 245 peak temperature on the circuit board. It's always considerably higher to compensate for the lighter components getting to the temperature faster and heavier components kind of lagging a little bit, but ultimately it's going to get reflowed, and it will be within that process window of the alloy that's being used. In this example, we have a preheat stage approaching 200, and then our peak is, I believe it's 235 or 240C. So right now the air temperature inside is approximately 222 degrees Celsius, and the board itself is 183. So as we're approaching that initial preheat stage, it starts to flatten out and allow the time to preheat the board before it's going to go ramp up to the peak temperature. Getting close to that 200 Celsius set point. And then it's going to go to the peak. In this case, it was 240C that was programmed. In terms of the delta between the red line and the blue line, there's always going to be a difference in temperature between the air and the product inside the circuit board. Depending on the mass, it can be more or less than what we're looking at right now. So the heavier the board is, the more thermal mass it has, the more of a delta we will see. Also, we program the ramp rates in degrees Celsius per second, so that dictates the delta as well. right now the circuit board is at 227 Celsius. Again, the melting point of the lead-free alloy is 217, and our goal is to get it to anywhere from 230 to 245, depends on how you program it. But it's always considerably higher than the actual melting point. And referring to the data sheet of the alloy, you can find the recommendation of what the desired peak temperature is. Profile is about to be completed. And now we're in the quick cool down stage. Built-in exhaust will open the seal between the exhaust and the heating chamber. And the blower inside is going to turn on. It's going to pull the hot gas out of the heating chamber, force it through the exhaust port, force it through filters, and then through the exhaust port that's at the back of the oven. And we can change the cooling time value. Changes to the settings are on the fly. If somebody wants to modify a certain time as the cycle is running, there's certainly that capability. And that's basically it.